Why you got when I'm trying to bring wisdom and enlightenment to you?
I love the wisdom and enlightenment. It's just that I never know what to expect.
Where it's coming from.
Or where it's going to come from.
All right.
Okay.
So this one is, I got Earth.
All right.
I got all manner of spheres in my office.
Yes,
right?
see.
And this is among them. Let me yank this off its axis.
My
here.
favorite planet.
Yeah, it's my favorite planet too.
Oh, good.
Yeah. The difference is, of course, in space, it doesn't look like this because in space, there are no color-coded countries.
Ah, there you go.
In space, there is ocean and land and clouds.
Nice.
And as nature intended Earth
to look. Funny how it works out that way.
So I just wanted to impress upon you how smooth Earth actually is.
Okay.
We think of it as, well, how could it be smooth? It's got hills and mountains.
Valleys.
And valleys and oceans and trenches in the oceans.
That's right.
And all of this. And so, and even this globe itself, it has bumps on it.
It does.
All right. So let's go to the biggest bump range. That would be like just above India and Nepal.
Okay.
So we get the Himalayas. Right. So you feel that.
Okay.
All right. So there it is.
Right.
So they're trying to tell you, yeah, Earth is not smooth.
Lots of bumps.
This is where they're trying to, and so it's not only there. You get it in the Apennines and the Rocky Mountains are over here, of course, in the United States, and then it's not slightly high the Appalachian Mountains, of course.
All right.
So you get little bumps. Some are bigger than others.
Okay.
All right. So they're just trying to give you the essence of the fact that Earth is not smooth.
Yeah.
But I'm telling you, Earth is smooth.
Okay.
Earth is so smooth.
So how smooth is it?
That if you were some giant and your finger was actually this big relative to Earth, if you close your eyes and rubbed your finger across Earth, it would be one of the smoothest things you ever touched.
So you're saying that we wouldn't feel these little representations?
Let me tell you why I don't think so.
Okay.
Okay. First of all, the actual height of these mountains, if Earth were this size, would be about the height of the depth of your fingerprint.
Oh, wow. And that's nothing.
That's nothing.
Right.
That's nothing. And so therefore, how much are they lying to you here? I'm going to tell you. Okay.
Good.
Okay. So you know how high Mount Everest is?
Okay.
You know how high?
No, I don't know how.
Okay.
I mean, I know it's high, but I don't know the actual.
You can't just recite
I can't recite the number.
So 28,000 feet.
28,000
to the summit.
feet.
Above sea level.
Okay.
Not above the land around it.
Right.
Above sea level.
Right.
Okay?
Okay.
All right. So this bump, by 28,000 feet, how many miles is that? 5.5, maybe 5.5, 6 miles.
Right.
Somewhere in there. Between 5 and 6 miles.
Right.
If you calculate how big this bump would be given the size of the Earth, it'd be 83 miles high.
This bump here.
Yes.
That's pretty wild.
Okay.
Right.
83 miles.
83 miles.
Yeah. So this is lying to you.
Right.
And almost all geologic globes that give you the bumps and the ridges and the thing, they're lying to you.
It's just a little exaggerated.
A lot exaggerated.
Exactly.
A lot exaggerated. So this feeds our belief that somehow Earth is a very terrained place.
Right.
Not only that, what is the highest point on Earth's surface above sea level? That would be, where did I go? Where did you go? There you go. That'd be Mount Everest. Do you know the lowest point on Earth's surface?
The trench.
Let's go around to the trench. Oh, I could have gone the short way. Okay. The Marianas Trench.
You just picked up a lot of frequent flyer miles.
So the Marianas Trench.
Right.
It's off the coast of the Philippines. Okay.
Okay.
So that's with the Philippine Islands there. So that goes down something like 35,000 feet. It's like 6 miles down.
Okay.
Okay. So that means all variations in elevation on Earth
from top to bottom
can be contained within a dozen miles.
Right. That's not a lot.
It's not a lot.
Not at all.
A dozen.
Right.
A dozen miles. How wide are we? Again, we're in miles here. Sorry for you metric folk.
Yes, exactly.
Okay.
By the way, catch up. If you are on the metric system, get with the program. America.
There's America.
America, damn it.
Damn it. So I don't know. So if you only have about a dozen miles across a diameter of 8,000 miles, that's the diameter of the Earth. That is small. That is so small. If you shrunk Earth down to a cue ball, in billiards, it'd be one of the smoothest cue ball ever built.
Right.
Ever.
Yeah.
Again, you'd rub your finger on a cue ball. I don't feel anything.
You feel nothing.
You don't feel nothing. And as what would happen if you did it on the Earth here. So that's all I'm trying to say. Earth is a very
smooth
sphere.
Wow. See, now there will be people who will say you are wrong because I can see mountains. And you are wrong because I can see valleys.
Yeah, it's because you are littler than than the bumps and wiggles.
That's very funny. Right. Kind of makes sense, right?
If you were an ant crawling on a beach, it's like, man, this hills and dales or something.
Right, exactly.
Oh, my gosh.
Oh, these dunes are amazing. Right.
You're just walking across them as a human being.
Right.
So it's just a matter of what your size is. This is part of the problem with flat earthers because we are so tiny, you're only seeing such a small section of this huge curved surface. It doesn't come to you across to you as it's a curved surface, because your exposure to it is so small. So this is part of what the cosmic perspective is, just rethinking how the world looks to you and ask, is there something fundamental about that? Or are you stuck thinking something is true that is not? Or thinking something that is not true that is.
Right. Yeah. And so with respect to other planets that we know of, I'll say in our neighborhood, forget exoplanets that we found, how smooth are we compared to them?
Excellent question. So it turns out the moon is slightly less smooth than we are.
Okay.
So their big mountains relative to the moon's diameter are a little higher.
Okay.
And so you know why?
Okay, why?
There's not as much gravity there.
Ah.
You know what the ultimate limit on how high a mountain is going to get on the moon? Is how much the damn mountain weighs.
Right.
All right? And you're holding it with just rock? Rock ain't infinitely strong.
Right, exactly.
All right? So at the base of the rock, can it hold it up, or will it start to succumb under pressure and flatten out? And so, yeah, there's a limit to how high the mountains will ever be on the Earth, just for that reason.
Oh, wow.
Yeah.
Yeah, and you never think of that. You never think there's a reason why mountains can only be so high.
Right. So, and the smaller the object is, or the less gravity it has, the more you can have a distortion relative to its size.
Right.
And that's why there's some asteroids that are potato-shaped.
Yes.
All right? They're not spheres.
Right.
Because their rocks can get any shape they want without gravity forcing it back into a sphere. So anyway, we live in Manhattan, which is about a dozen miles top to bottom.
Right.
That's the full difference between the lowest point on Earth's crust and the highest point on Earth's crust.
Wow.
And you can drive that in 10 minutes.
I was going to say that's
not
nothing.
in traffic, but you can.
Yeah. Well, yeah.
Yeah, but it's nothing.
Right.
It's nothing.
So
Chuck, there's the story right there.
It is.
Okay.
Right.
Oh, wait, one other quick thing. Since gravity will prevent mountains from getting very high, you might ask, well, what object has the strongest gravity of them all?
Ooh.
Okay, so you get neutron stars.
Right, that's true.
Which is
a failed black hole.
A failed black hole, yeah. And they don't want to be called that, but that's...
Sorry, neutron.
Neutron star. So neutron star, very severe surface gravity. And in fact, let me tell you how severe the gravity is. If you had a sheet of paper on it, the thickness of the paper, to ascend the width of the sheet of paper would be like you climbing a cliff face in the energy you'd have to expend to do that.
Wow.
So, in fact, neutron stars don't let anything get too far out of alignment there.
A little clingy.
So neutron stars are the smoothest objects in the universe.
Oh,
for that reason.
Because of the gravity.
Because of gravity.
Yeah,
that's right.
It's almost like it's compacting.
You know what gravity wants to do? It wants to pull every part of it as close to the center as possible.
Come here, I love you.
And if something's a little sticking up a little too high, it's going to yank it back in.
That's right. Get in line.
So there you have it. Earth and its bumps and wiggles.
There you go. The Earth, smooth but not flat.